Welcome to this FLUIDOS Node demo. The FLUIDOS Node is one of the main components of the FLUIDOS ecosystem. It basically transforms requests for cloud resources into actual, ready-to-use resources. But what is a FLUIDOS Node? We can see it as a Kubernetes cluster composed essentially of pods that implement the logic like the local resource manager, which manages the resources that will be offered to other clusters, the rear manager, which transforms requests and later bought resources into something working, and the rear controller, which communicates with other FLUIDOS nodes. The main task of the FLUIDOS node is to contact other FLUIDOS nodes to look for the needed cloud resources, negotiate them, and define a proper contract. All these steps are achieved thanks to the implementation of the rear protocol. In platforms like Artifact Hub, you can find information about the installation setup through Helm chart of the FLUIDOS node. Be aware that there could be different options of the installation. We suggest to take a look at the documentation associated. The FLUIDOS node can be easily installed thanks to our Helm chart into any Kubernetes cluster if Liqo is installed as well. This can be easily verified through the Liqo command line tool. Liqo is the technology which establishes the communication between clusters and enable the cloud continuum. Once you have installed FLUIDOS node, you can check that the three previously mentioned pods are running as well. In a scenario of a consumer and a provider, both FLUIDOS nodes, the provider needs a set of resources to offer to potential consumers. These resources are called flavors and are managed by the local resource manager. The concept is the same as the rear protocol. Therefore, we have different kinds of flavors, such as Kubernetes slices, services, sensors, etc. In this demo, we will focus on the Kubernetes slice flavor. This kind of flavor represents a subset of computational resources that a provider offers. In FLUIDOS, such a kind of flavor can be created by labeling Kubernetes nodes with a specific label. The local resource manager will step in to map them as flavors. These are Kubernetes custom resources that can be both seen from command line or through the FLUIDOS dashboard if previously installed. The first step of a resource request involving the FLUIDOS node starts with the solver. It is the actual entry point of the FLUIDOS node and represents the characteristics of the resource request. Starting from the specific resource type, Kubernetes slice, service, sensor, etc., you can identify the related filters. Depending on the metric to be filtered, different types of filters are available, such as match filters for exact values or range filters to filter between boundary values. The solver owns three flags: find candidate, reserve and buy, and establish peering. The first two correspond to the rear protocol phases: list flavors, reserve and purchase, while the last one is a FLUIDOS-specific phase to transform the bought resources into something usable in your cluster. All three flags and corresponding phases can be handled automatically by the solver in FLUIDOS node by setting them to true. Beware, this choice involves the use of logic on the choice of flavor and its subsequent configuration that is automatic, very simple, and often not suitable for specific use cases. In that case, as we will do in this demo, we choose to set only the find candidate flag to true, and then let the solver discover remote flavors, here called peering candidates. The next steps will be done manually, but remember that using an external component can also interact with the FLUIDOS node resources and implement better, automated decision logic, as from an orchestrator. At the end, the solver is nothing more than a Kubernetes custom resource that can be created with an appropriate manifest, filled the fields and applied to the cluster. The game starts now. Once the solver is applied to the cluster and it has solved the find candidate phase, you get different flavors from remote providers called peering candidates. These are Kubernetes custom resources with specific characteristics obtained by the remote flavors. Once you have chosen the wanted peering candidate, you can reserve it through a reservation custom resource applied to the cluster. The reservation is the second step of the FLUIDOS node process. It describes the intention of the consumer to reserve a peering candidate with a specific configuration that depends on the flavor type. Each kind of flavor can require a specific configuration. In particular, a Kubernetes slice requires the actual dimension of the slice you want to reverse and then buy it. Through the reserve flag, you will only reserve the flavor. This action will return the transaction, which is a temporary state of reserving a remote flavor. The transaction is not only a state, but it is an object, a real Kubernetes custom resource. Be aware, it is temporary and has an expiration time by which the user, either manually or through an automatic mechanism, must decide whether to purchase it or not. Now that we are sure that we are purchasing this specific peering candidate, which has been previously reserved and whose reservation has been confirmed by the transaction, we can finally proceed with the purchase phase and get our contract, the last step of the negotiations but not the last of the FLUIDOS node. You can complete it by applying a patch to the custom reservation resource, setting the purchase flag to true and thus completing the transaction before the expiration time. Now the flavor has been purchased and you have the contract with all the information about the purchase. In addition, there is data on how Liqo peering can be performed, which will be used in the last step. The contract itself does not implement the actual cloud continuum. This is performed when the allocation phase starts, which is the final step of the FLUIDOS node. The allocation is a simple custom resource. Of course, it is strictly related to the specific contract, so flavor to allocate, since the strategy and the outcome should be different. The specific manifest of this customized resource is not particular, but requires reference to the contract with the flavor in question. In our demo example, since we are treating a Kubernetes slice, it is allocated through a simple Liqo peering between the consumer and provider cluster with an enforcement over the amount of shared resources. The FLUIDOS node job is now complete, and all 4 steps have been successfully executed. Let's verify that everything is functioning as intended. Let's create a namespace in the consumer cluster. Offload it through the Liqo command line or Liqo specific custom resource. In our demo, we will tell Liqo to offload all the workload to the remote cluster, so the provider cluster, to use the resources that we have bought. We can now create a workload in the namespace, like a Nginx server. The pods of the Nginx are created and are reachable without any issue thanks to the cloud continuum established with Liqo and negotiated with FLUIDOS. A seamless working cloud environment have been created.